Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
First, I would thank you very much for coming over tonight, and we'd love to have you here. This is the first lecture of a series of state of art of technology, and so we're going to have in every month, second weekend, second Tuesday evening, from 6 to 7 p.m. over here, and this will be sponsored by different society today. We're going to have Internet of Things. It's like consumer electronics and computers. And then we're going to have computer society, signal processing society, and each different aspect of what's going on in the world are most exciting things. And we have pizza here. And if you like, have some pizza and go to back and pick up the pizza and then come back to enjoy our lectures by Joe Dicker.
Not a doctor.
No, Joe is been with us for many years, and very active. Was area chairs, was various different positions, and pretty much is a guru of Seattle section. And he became our new fellow, 2015. And so congratulations to Joe. And he give distinguished lecture all around the world and do all kinds of wonderful things on the board of governors for Consumer Electronics Society. It's a wonderful person.
But the thing that we're most excited about is that we are going to be chairing the Global Humanitarian Technology Conference here in Seattle this October.
Yeah, and Joe is our chair.
And she's the vice chair this year. She'll be the chair the following year.
And so we were going to have a very big event, and hope all of you will come to join us in the conference and help out volunteers, get things, good humanitarian technology area things started, get very active in Seattle and connect with the world. So please go to get your pizza and come back here, and then we will hear what Joe tell us.
Today. Now, is this mic lit?
Yeah.
Good. Yeah. I might as well introduce myself and keep going, because we have, what, 41 minutes? All right. You heard the introduction. The one thing I would add to that is that I worked here. Lucky me, starting in the fall of 1992, and I retired after 8 years, time off for good behavior, in 2000. So, I want to talk about some problems related to building the Internet of Things. And in particular, I'm going to describe a particular solution that uses Bluetooth Low Energy. I want to talk about the problem to solve. I want to talk about the ways we are considering connecting the low energy world to the Internet, and then various ways to map that all through, and then to talk about what to do with this and how it would work. Given the time, I'm going to be a little crisp, but I hope there's time for questions at the end, because if one of you is brave enough to ask a question, it's likely that several of the others would like to know the answer, and that means you're paying attention. Okay, the first problem to solve, I'm a connectivity guy currently, and I'm interested in connecting the low energy world to the Internet. So today, this is industry hype. You can hardly open up another magazine article online hyping the Internet of Things. There are going to be probably trillions of amounts of money invested in this. And my wife keeps asking me, who cares? why would I care about these things that I want to pervade my house with? How many of you have seen recent, and I mean the last 2 days, articles on the web about people hacking into people's cars? Anybody? Yes, several of you. As an aside, I work a lot on security, and I believe that security for these things is a forethought, not an afterthought. I believe that the customers will shun any devices that appear to be leaking. And if anyone wants to kill this market quickly, they'll produce a lot of stuff that gets hacked. So, to answer my wife's question, I'd say in this whole space, somebody has to come up with an application that would get me to want to buy the device. So for example, 2.5 years ago, I bought a Fitbit. Well, that's nice. If I knew in advance that buying a Fitbit would allow me to lose 20 pounds, that's a sale. But that's just an attraction. That doesn't mean it's what it's actually going to do. And as you can imagine, willpower matters more than what this thing tells you. But that's just an example of the attraction. Then I might use it if it actually connects to the world. My Fitbit will talk through low energy to my phone or my iPad and tell Fitbit.com how I'm doing or not doing. And so it's starting to accumulate information to tell me. It gives me little electronic rewards if I walk so many steps per day, et cetera, et cetera. A question to always ask is, where is the intelligence? Is it in the device? Is it in something that you control? Is it up in the cloud somewhere? And to pick an example, you all know, because you know what the Connect is, that the Connect is something where there's intelligence in the device staring at you, but there can also be intelligence in the complete Xbox, and it can go up to the cloud and back. You know about Cortana, and you know about Siri, which record your voice, and they can do voice recognition and speech recognition based on what you tell your cell phone. And that's where the intelligence is in the cloud, not in your hand, right? So always ask yourself, where is the intelligence really? And if the intelligence is not where I can see it, someone can get to it. And like I say, you got to be able to trust it. Otherwise, people are going to run away. We may, in fact, sometime have people looking back and now as the good old days before someone could hack my car. So, the Bluetooth SIG, where I work for a living, has identified 3 different ways to connect low-energy devices to the internet, depending on the use case. The first one is, let's take an existing device which doesn't know where the rest of the intelligence is. It's just what they call a generic attribute protocol server. And the RESTful API allows the device going through a gateway from anywhere to attach to and control this device. We don't need to do anything different outside of the gateway. The second way is if you have a really smart little client app and you teach it about HTTP. So you can tell it to go through a gateway, through a proxy server, to talk to the internet. Make sense? You all know what proxy servers are by now? Maybe? And the third is to put IPv6 intelligence directly in the device. And that's the subject of today's conversation. So, I just walked through these, and this is sort of a picture. This probably does not light up. Existing stuff, you can go through a gateway that's RESTful. Does anyone here know what I mean by talking about RESTful? Some. All of you who've been on the web for the last almost a generation now know what HTTP that appears in the URL for a place you want to go, right? HTTP stands for Hypertext Transfer Protocol, and it is a RESTful design. We're going to do more of this going forward. Stepping back, I was describing if you teach this thing to go back out through a proxy to the web. So for example, a pair of these things together, they're speaking native Bluetooth Low Energy, and they can go out to the server first, punch a hole in the firewall, which needs to be there, and explain to something out here where they are. Third point is if I put IPv6 or something other native IP directly in the device, in which case it needs to talk through a border router from clients and servers out on the web. Here's what it might look like in your house. There are two common ways to find internet access. One of them is 3G and 4G through your phone in your pocket, or if you've got some kind of broadband modem, cable, DSL, whatnot, from an ISP, and you need that firewall so you don't get hacked. And then you can talk to a gateway in your house, which is doing the 6L border router to talk to all these smart nodes in between. This is a good time to check for questions. Is this mysterious or does this make sense? I've got 35 minutes. Okay, so let's suppose I want to connect these things. Who here does not know what the Internet Protocol is by now? It was such a wonderful thing that we built it and reconnected the world. Unfortunately, the people who designed the Internet Protocol were not aware of how popular this was going to become. So when they designed it, they had 32-bit addresses, which is 4 billion unique addresses. And that's no longer enough unique addresses to address every living human on the planet. So if you're going to have more than one gadget per person, for sure, IPv4 is not sufficient. And we're imagining, maybe in a nightmare, tens of devices per person, and that means we need a lot more bits. So today, to function, we have network address translation. We were working on network address translation in Microsoft 20 years ago. That's when a set of local devices are mapped into a single external device, and port addresses are used to map particular functions inside the protected network to the outside. And yeah. So IPv6 now has a huge address space. So to put it in perspective, 32 bits is not enough to address every living human on the planet. 64 bits is enough to address every living insect on the planet, if you can imagine how large that is. And 128 bits is that much larger. So if we've now defined a system that can basically address anything, then we've got a foundation to start connecting to all those devices we might conceivably want to have. So IPv6 has a larger header. And if you want to adapt this to things that are light, you have to do some adjustments. Otherwise, you spend so much time on the air just shipping those 128-bit addresses back and forth that you don't have time to do anything useful. So the IETF, Internet Engineering Task Force, has been building a way of mapping IPv6 to smaller devices. Their first target was the 802.15.4 radio. Now, to translate that into English, how many of you ever heard of Zigbee? Right. That's the radio it uses. Z-Wave also uses that radio. There's a cable modem keyboard control function that also uses 802.15.4. And originally, their original plan was to start porting this to a new and interesting radio, Bluetooth Smart, low energy. But the people from the Zigbee space said, well, we own YPAN. So they've just decided to name it 6LoW BTLE instead. And this is a decision that happened like 3 weeks ago when the document was in voting. So this is sort of hot off the press. So stepping back, there's a technique for adapting IPv6 to small devices. It's been done to the first radio. It's now been done in ballot for the second radio. And it's going to be applying also to 802.15 radios and so on. Yes, ma'am?
That sounds sort of in principle like NATI, right? So what's the big advantage to having native IPv6 addresses? If you're doing some kind of a set, right, and mapping it.
Well, what they do, basically in the border router, you have to compress the addresses to the nodes. And I didn't want to get deep into exactly how 6LoWPAN works if that's what's going on. It's not the same as NATing. It's more a compression.
What are you gaining? I understand that it's technically different, but
It's
why are you
IPv6.
going through all this trouble, to get native IPv6? What's wrong with NAT? Why would they?
It is IPv6. Exactly. It's an IP over full definition, just like IP over Ethernet, IP over Wi-Fi,
Right.
IP over 15.4. It's just like that. So that's a high order bit. There's no NATing.
You know where to find me, so if I don't answer you enough today, we'll talk.
Okay.
I'll give you a card later. So, as he was saying, IPv6 over foo. All right, problems to solve. First of all, connecting it to IPv6 and all those giant addresses and all the other functionality. The topology, the limited packet size, because if you want these radios to be small and cheap, you don't want to put, has anyone looked at the specifications for the newest Raspberry Pi? Nice machine. You could run Windows 8 or Windows 10. Windows 10 is going to run on it, right? That's way too much functionality to put in a small, cheap thing, right? We're talking about things that probably have 16 or 32-bit processors. They don't have memory management. They will have much less than a quarter megabit of memory. And because if they get larger, they're, first of all, going to consume a lot of power because they're going to leak. And then you'd start putting them into lights because you have to put it in something that's powered all the time. You have to do service discovery and you have to do security. That's just the top level list. Okay, so the characteristics are you want it to have a small packet size. If they're large, it's not low power anymore. You want to have it shorten the MAC address. You want to have low bandwidth and low duty cycle. You can support star and you can support mesh. Does anybody know what I mean when I talk about a mesh? Good. All right, you're trying to keep it low power, meaning you want it to run on a battery, if not a coin cell, rather than being lines powered. Obviously, you want it cheap. You want to be able to support a lot of devices and have a technique that supports a lot of different things that are distinguishable and groupable in some way. You want it to be ad hoc deployment because our customers are not going to be your corporate IT department. The people who deploy this are going to be basically anyone. And we have to design systems that can stand it to be installed by anyone. You want the devices to sleep a lot to save power, and assuming that you have at best a 32-bit processor, but probably a 16. So you want to what the border router does is it looks at the first packets that are sent in, and it recognizes things, and it'll compress them so that on subsequent uses they're much shorter. It's actually pretty simple. And then you compress the subsequent packet headers as well because you already can assume things about what was done before. But you still have to do address resolution, and you still have to handle different kinds of radios, and some applications will have different parameters to optimize. Without a lot of time, I'm not going to get deep into that. All right, so we sat there in the Bluetooth SIG, and 2.5 years ago, the IETF came to us and said, hey, can you give us the foundation so we can put IPv6 in these things? And we said, okay. And being the Bluetooth SIG, we take twice as long as we ought to be, but we eventually finish. This was adopted in December. So we want to build new use cases. The market for 6LoWPAN is expanding. Who has heard of Thread? Yeah, okay. There are more than 100 companies and consortia who think they're going to tell all of us how the Internet of Things is going to be wired up. Thread is one of them. You'll hear about more of them later. People have been putting 6LoWPAN into systems for managing power today. If I was to step back in a moment and say, so what's a smart house? Any ideas? Oh, come on.
Smart house?
Yeah.
Yeah.
And how do you measure
Thermostats.
the IQ of a smart house? Some people think a smart house saves them money on power. Close enough. And a lot of the original applications of 6-LoWPAN are in that space. Some people like to have their entertainment to follow them around the house. I'm not one of them. And that's what DLNA is for. Some people want better control of their security and who's in the house and can I turn lights on and off, et cetera, et cetera, et cetera. A lot of work is being done in that space now. And of course, some people, like my dear wife, think that they want a house that takes care of itself. That not only will it vacuum itself, maybe it'll clean the toilets. I had to explain to her that that's probably a ways off. And it's more of a physics problem than a communications problem. There's an organization called Internet Protocol for Smart Objects, IPSO. It is closely related to, but not the same people as the IETF, Internet Engineering Task Force. And this presentation is about how to hook together a system with a Bluetooth radio using a particular profile, talking to 6-low BTLE, talking to this. That's the stack. So let's start with the smart radio. And in this design, the ordinary Bluetooth tools are used for finding and connecting to a device from something in the center, but they're not used thereafter. There's a feature that's in the second version of Bluetooth Smart called ConnectionOriented Channels. And this design takes a connection-oriented channel, sets it up with a minimum MTU of 1,280 octets, which is big enough for your average IP packet, and lets it run underneath the upper stack, allocated a fixed channel. And this is what it looks like conceptually. Here's the node. It's got the regular radio. It's got the link layer. How many here have not heard of the Open Systems Interconnect model by now? Good. This is the multiplexer layer. These pieces are used to make the connection, but afterwards it runs that stack. In fact, I need to change that because they just renamed it. I didn't catch it in all the places. Yeah, so here's a border router which connects to IPv6 sources out here and then connects them to all the child devices. So in regular Bluetooth low energy or smart today, it's low energy because it's designed to be very low duty cycle. You can do a transaction of advertising for attention, forming a connection, getting and receiving a command, and turning off again in 3 milliseconds. How often do I need to turn off the lights in this room? Maybe twice a day, on and then off. So if I'm doing that, the amount of actual communications time is tiny. And for a lot of other things that you can imagine in your house, the actual time they're going to be on or the time when any changes occur, those are tiny compared to how long they're on. And that's how you can build things that run on coin cells. So ordinary packet sizes are 23 octets. Even a long attribute is 512 octets. So transferring a long message, it costs a lot of battery time compared to 3 milliseconds. Common internet protocol packets are 1280, or they can be that large. So here's what the stack would look like inside a single Bluetooth device. It has access profile for finding things, profile and attribute protocol for controlling things once you found them, and the multiplexer, the link layer, and the physical layer. Applications, profiles, and services are, what does this thing do once I've decided? What causes me to want to buy this thing? Right? I didn't buy this thing because it has LE in it. I bought it because it measures something that I consider important. So the connection-oriented channels is we're now bypassing the simple mechanisms for controlling things in a device and going to something that's less constrained in terms of how much data it can deliver, to deliver it to something that's beyond the scope of the Bluetooth SIG. Let's see. Yeah, so instead of, let's suppose, for example, I have something that I can turn on, and I can have a characteristic that's simple automation I/O, and I write a 1 to it or I write a 0 to it. In ordinary AT and GAT, that thing will take, the single transaction will probably take well under a millisecond. If I have to deliver longer pieces of things that boil down to turn the light on and off, I'm choosing to spend energy in other ways just to have it a more general tech method. Does that make sense at all? Okay, so we added long packets, we made room for this stuff, and we let devices that live up above the BTLE layer decide whether to switch or accomplish any other action that we want. So why would I want one of these things? Like I say, there are probably 150 companies or consortia that want to tell us how the IoT is going to work, and they're not all correct, because most of them will have few followers. You can classify them by category. IETF, Internet Engineering Task Force, we've already talked about. All-Seen is an organization that Microsoft is a member of, developing plumbing for connecting devices. MQTT and, don't ask me to recite all the names. There are automotive-specific things. As you've seen, there are people are wiring up cars and then connecting them to the internet. God help us. There's healthcare. Has anyone ever heard of IEEE 11073? I expect most of you have not. But 11073 is a set of IEEE standards for talking to health and sports and fitness devices. It defines what the data looks like. It was designed originally for the convenience of organizations that write the applications that use these semantics. And in the Bluetooth world, what we've done is wrapped all that stuff up so that lots of these things now speak that language or speak to a translator that speaks that language. Home automation, big complicated space today, but we're trying to drive some convergence, industrial, utilities, and smart grid. So, home automation. The organization IPSO has been building a set of specifications of semantics for how you talk to all these different parts of a house. And so the point, of course, is that if I want to write a bunch of applications, how many of you remember the history of computer operating systems? Some of you should, right? The applications writers are the actual proxy for the end users. The end users are the ones who actually spend the money on the product. And the applications writers want to have as much commonality as possible of the things that they're going to write to, so they don't have to write many different versions. Way back in the mid to late 70s, we first started building personal computers, and the people writing word processors had to write a different printer driver for every different printer. And that was before Microsoft came and other operating system companies came along and abstracted printing and abstracted communications and all those other things. So the applications writers would like to be less confused about what's underneath. The convergence I'm interested in driving is convergence on the models from IPSO. Because if I can build systems that then translate to that using things like AllJoin, then I can attract those people and build markets. So I want to decouple the devices from the dedicated application services, right? I talked about writing to a printer. I don't want to have to deal with a lot of different abstractions to turn a light on and off. It's always an advantage in software development to not have to reinvent wheels. Do it once and test it. I want operability across a lot of machine-to-machine protocols. There are several examples that I will quote later and before that can be translated into the all-join connectivity system. And I want the developers of the applications and of the end gadgets to concentrate on what they're really good at and not having to reinvent all the connectivity stuff in between. So these people have been writing applications that run on top of 6-low YPAN in homes. And with the development of 6-low BTLE, we can take the same applications and run them on a different radio, basically. And they use something called CoOp, which is constrained applications. I think I've got a slide on CoOp. Now, where is? I had a slide here. I'll jump back and forth. I want to explain what CoOp is. You've all heard of HTTP. CoOp is designed for lightweight stacks and uses UDP rather than TCP. So it doesn't count on the system underneath it to keep track of reliable delivery. It just sends the message and moves the timers up to a different level. It's very similar to HTTP. In fact, it's kind of a subset of it. And there are now web browsers extensions that you can get that speak to CoOp. So imagine maybe the next version of Internet Explorer might have an extension that knows how to talk to these lightweight home control things. Let me go back up. So these people decided to take the most commonly accessed items, 18 of them, and build what they call a starter kit. And so here's an example of a smart object. They've built models for how to talk to a fridge, how to talk to HVAC, and that means heating, vacuuming, and air conditioning, controlling your house, how to talk to random digital inputs to random actuators. I'm not going to explain the French stuff. So specifically, it talks about general I/O, generic sensors. How bright is it? Is somebody nearby? How warm is it? How humid? Measure power in some device. Sometimes you want to measure what's the load behind a power source. You want to control lights, of course. You want to turn power on and off. You want to measure acceleration in some things. You want to measure magnetic fields sometimes, measure barometric pressure. These are things that are in the starter kit. The people developing them have actually been working on probably 100 different devices. And again, if they're doing such a good job of doing 100 devices, I don't want to have to do it a second time. So to take just one example, drill into digital input. It wants to know the current state. It could have a counter, so it can say how long it's been in the current state. It can say what polarity it is. I might want to specify a debounce period. How many of you have designed embedded systems where you have to deal with what is called debounce? I see a few hands. Good. I used to work on video games 35 years ago. That's where I learned about debounce. That's why I'm a fellow. And yes, you have to be very careful about how long people are pushing the buttons and whether you believe it or not. You want to have you can provide for edge detection. You can reset the counter that's keeping how long it's been toggled. And there can be application types like people are putting air pressure sensors in cars. In my car, in fact, I was driving around and the sensor went on. Turns out it was a sensor failure, but it started telling me that I had an air pressure problem in my car. We should get used to that. All right. Any questions about that before I proceed? Because I don't want to run. I think I have enough time. Here is some more detail on the things I showed you before. Here's the radio part. Underneath, this is connection-oriented channels. Then we start adapting that to the IPv6. Then above it, we put CoOp, which generates UDP traffic. And above there, I put something, an application that's trying to drive a smart object of any kind.
So Joe,
Yeah.
on that slide, where would the lightweight M2M transport fit?
Well, as a matter of fact, lightweight M2M maps directly into IP smart objects.
Okay.
I've got a copy of the document, and it's full of This implements this thing in lightweight M2M. So it's an attempt to bring everybody together. Good question. I think I went back to this already. I should move it to a different place in the next slide deck. So, like I say, there's a lot of them trying to tell us how it's all going to work. At CES show a month and a half ago, the chief executive of Samsung, which I'm sure all of you have heard of by now, he says that in 2 or 3 years, 80% of all Samsung's products will be enabled for Internet of Things. He says, all the work on standards has not succeeded so far. We need help. Please come. We can't do this alone. If I knew who he was, I would write him a fan letter, because that's exactly the right attitude right now. And so he needs the help of all the rest of us. There will be Darwinian evolution. When you have a lot of choices, customers will be attracted to something that might be useful to them. They'll keep it if it connects to things that they care about, and then they will not throw it away if they don't discover that it can't be trusted. We'll support all these use cases that I talked about up above, because Microsoft may decide to take a technique and bring it to one group, and CSR may take a technique to another group. Nokia, for example, has been one of the people trying to drive IPSP. They'll take that into IETF. They'll spread it however they're going to spread it. The Bluetooth SIG itself is not going to be telling us how this works. I think I left out my favorite, I left out my best cartoons. What I did instead is give you 3 slides worth of references. So I'm providing this so you can go find all this stuff. So how IPv4 and v6 work, network address translation, where you can find the engineering task force, different kinds of radios, and that takes too much time to explain it all. I was talking about health standards. This is the I11073. All-Seen Alliance is the group that Microsoft is a member of. Machine-to-Machine Connectivity, Open Mobile Alliance. Yeah, someone was talking about lightweight M2M. Smart Grid is an IEEE standard for how to control power usage in homes. And there's that starter pack. So I invite any of you, if you are curious about this stuff, to download that and see what it has to say. Here's how to find me. If this was my own computer, I'd show you a couple of cartoons. One of them, a few years back, Dilbert had a cartoon where Dilbert's boss gives him something that's basically a Fitbit. And Dilbert is so excited that his boss cares about his health. But in the last frame, Dilbert and the cat are saying, this guy is not breathing hard enough. We should give him some more work. Get used to the fact that all kinds of people can get access to your information and they may not be friendly at all. The other cartoon that I like, it's about 15 years old now, about networking houses and refrigerators and all this. So the man comes into his kitchen and his refrigerator has an eye on it, sort of like HAL 9000. And he says, Dave, give me a beer. And the refrigerator says, the scale in the bathroom is reporting disturbing flab abnormalities. I can't do that. And the guy is saying, I don't want my equipment to be smarter than I am. But imagine someday our houses will care about our health so much that they'll be intervening constructively. All right. You know where to find me? Yes, sir.
Could you just describe what the current version is of Bluetooth and also where beacons fit in?
Beacons.
Which version beacons are supported?
Okay. Apple and some other companies are making use of beacons. Beacons are about, where is something? A Bluetooth smart server will generate advertisements. There are 3 channels that are chosen to avoid all the Wi-Fi channels in the 2.4 gigahertz band. And so a device will be saying, hey, I'm here. Hey, I'm here. An older version of that technology. Who's heard of Docomo? Docomo is to Japan what AT&T is to the United States. So Docomo makes a whole lot of money off of beacons and commercializing where things are. So they had this problem a few years back because they wanted to do indoor location. But GPS doesn't penetrate the ground, right? Shinjuku Station in Tokyo is the largest train station and the largest shopping center in the world. And Docomo wanted to put beacons that would radiate the message, here's where you are, here's where you are, here's where you are, and here's how low you are, how high you are. So they could tell which stores you were near, and they would have a separate record of what the specials were at this store at this time. So Apple has been popularizing iBeacon, but they didn't invent it. It was invented in Japan. And all they do is they take these things, stick them on the wall. They're powered by light, because the power is low enough that they'll run basically forever on the ambient light in the place. And they're programmed with their location. And all they do afterwards is say, I'm here, I'm here, I'm here, I'm here. And they run forever. They don't have to be maintained. Just don't cover them with paint. And they'll stop working.
So the notion of doing, different device types over IP, over Bluetooth, seems to be in some sense competing with the notion of Bluetooth-specific profiles that don't have IP in the middle of it.
Exactly.
So how do you see the Bluetooth SIG going forward? Do you see that as being that they'll continue doing that and competing? Do you see that as a dead end? Or what do you see looking in the future?
I don't know how it's going to resolve, but I believe that there will be more than one choice. In fact, I am preparing to make a proposal within the Bluetooth SIG that what the Bluetooth SIG should do is take the IPSO starter pack and create exact GATT equivalents for each of those 18 items. Because that means that if I'm an applications writer and I want to write to IPSO and it translates to a gateway, which is near a bunch of low energy devices, if they don't have IP in them directly, they can convert directly into native AT and GATT and drive the devices. And the devices will be lower power because they'll be lighter, but the applications vendor still sees the same thing. I think that might be a winning strategy, actually, but I have to convince some other people to agree with me.
So your point is that they have to use the same schema and then the transport can be...
The same semantics.
Yeah.
Schema is the right word for it. There was hand.
I got one. I think it was somebody before me, but...
Yeah?
Oh. So
Go
one
ahead.
of the things I've been finding is a lot of people expect hardware to be commoditized and you don't make a lot of money on it. So they tie it into their service and they figure the money's gonna be in the service, money's in the service. So you're working for open standards where anybody's service and anybody's device and anybody's app can all work together. I want that. The problem is I'm finding like Wink, for example, which is available at Home Depot. Yeah, we're kind of open in a way if you can, talk to us in our way, but everyone wants to own that cloud service because they think that's where they're going to monetize.
That's right. That's right. Because they want to hold on to something that they control, something that's unique. And, I used to work at Microsoft. We wanted open standards to apply to everyone except us.
We want to apply the implementation of the open standard.
Right. Well, 22 years ago, I got away with telling a joke to Bill Gates. So, Bill, how many Microsoft engineers does it take to screw in a light bulb? He says, I don't know. You tell me. I said, none, Bill, because you will declare darkness as standard. He gave me good stock options later, so it didn't piss him off too much.
Well, so what I see is all these vertical stacks, which frustrate me because I'm trying to, build out a smart house, myself, to do these things. And, my video system is different. It's got its own stack. My alarm system's got its own stack. My Wink's got its own stack. The stuff I'm building is, I'll talk to anybody that I get you through Node.js, but,
This is going to be complicated for a while, but to step back, so Samsung is has joined the Thread group. And the Thread group today uses 6-low YPAN and things that look a lot like IPSO over them. So I was talking to Samsung at CES month and a half ago, And they said, oh yeah, this one, the only tested parts are 6-low YPAN today, but we've already got Bluetooth Low Energy into it, and we're going to try to sort it all out and make it open 6-low BTLE also. So that's the direction they're headed in. And Samsung will still add some kind of proprietary value on top of what they do, and that's okay because people want to have a profit motive. I mean, that's what pays for this building, amongst other things. But the boundaries of what's proprietary and what's public will get pushed back. I would suggest that in this space, some of the winners will be the ones that are more open than the ones that are less open, because the ones that are more open can attract more support. Microsoft learned that big time decades ago, okay? Bill Joy, who was a college buddy of mine, said, you should design your company on the assumption that not all of the smart people in the world work for you. And so they built not an open source, but they built an open API Windows system. And working with Intel, they built the PC industry, which still has life in it. And when I look around the world, the people who have at least open APIs, if not open source, attract more support. And you all know the success of Linux. And you might know that AllJoin is built on remote procedure calls in Linux. So it's going to attract people to add value on top of it.
Oh, that's okay. Go ahead. Okay, you kind of mentioned it in one of your former slides that Wi-Fi has Bluetooth 2.11p, I remember.
Oh,
Is that true?
there is in development going to be 6-low system over 802.11 as well.
Okay, so how do you see the future of coexistence between Bluetooth?
Well, if the applications are disconnected from what the radio is, it's better for the applications. And so there are some applications for which I'd say Wi-Fi is a better use than 15.4 or BTLE. Anything that needs a lot of data or that needs the 100+ meter range, then yes, you want to use that. And if the same 6-low IPv6 system lives over all these radios, that's attractive to me as an implementer, and it's attractive to me as someone trying to build a system that meets actual market needs. Does that make sense? Speaking of which, another friend of mine who is also a distinguished lecturer in the Consumer Electronics Society wants to come out here and talk about his ideas about home networking and whatnot, and I would like to know who I should connect Bob Frankston to here. Any volunteers? Anybody who works on this stuff here at Microsoft?
You can send it.
I'll send him to you.
You know, the financial industry went through a very similar thing, trying to standardize the communication between banks and so on.
Mm-hmm.
And they finally went to EDIFACT, and that's pretty much the international standard now.
Yep.
There was a lot of basic principles that are completely missing from what I see here. The whole concept that as the protocol advances, you send a code which tells you which version you're using, and to be backward compatible, so it's possible to upgrade parts of the system without upgrading the whole system.
Does EDIFACT do this also?
Yes.
That's standard consumer, standard computer design.
If IPv6 had compressed addresses, much of the complexity of this stuff would disappear, wouldn't it?
Well, the complexity appears briefly when things are found and connected. The 6-low border router recognizes what happens when things are first discovered and hooked up, and thereafter things are compressed. Does that make sense? So it occurs infrequently. If it had to happen on every single transaction, it would be a much bigger cost and it wouldn't save you anything at all. Does that make sense?
So you have to deal with the whole IP address when you're configuring it, and then after that...
Right, that's correct. So it's still, it's a lossless compression, if you understand the difference between that and lossy compression.
Yeah, Right. For instance, even old, if you remember the antique computers, 1620s and 1401s and so on, it had a variable length number, and they never had to hold as long as it could be because there was no limit. And if they went to a coding system like that, you wouldn't have these issues, except that if you send too big of an address, you run out of memory or something.
A lot of the routing that's done in the internet is done by really optimized fast hardware. And that optimized fast hardware knows about 32-bit and 128-bit addresses and not a lot of variability in between. Yeah, I can see building all that out of plain transistor.
32-bit address, you still have to pay for a 64, right?
Yeah. Another question?
I have 2 questions, if I may, Joe. One, will Thread support IP smart objects? And 2, is the OMA device management a smart object?
Yes. Okay. In reverse order, there are explicit references in IPSO for OMI lightweight M2M. And that's why all of those are listed in the references. And the fourth is, I have found the people that are working on the Thread stuff for Samsung, and I'm trying to find out from them whether they're planning to use IPSO or not. And the answer is, I have no idea. I'm trying to wait for them to get caught up in their email.
You probably see on Sunday night there was 60 Minutes, and Leslie Stoll was in the car and they hacked, so she couldn't stop her brakes. So it can be a big liability. Is there some way we can build in to have security so nobody can hack in to do those things, or your houses all get opened up?
Doors are being opened before locks are being installed.
Your things get extracted.
I mean, take a car and connect it to the internet. That's a door. The question then is, where are the locks? One of the comments that was made, because I saw the same 60 Minutes, is that the manufacturers differ in how they handle that. And I would say, at this point, if I was going to go buy a new car, I would ask them how they control this now. And I wouldn't buy the car if they didn't have controls built in.
This is inherently insecure.
Duh, yes. No, I've been talking about nobody wants their body hacked and nobody wants their house hacked, and this is an example of nobody wants their car hacked either. I mean, we've been connected for a while, right? Many of you are familiar with OnStar by now. So you've had at least a 2G level connection to General Motors for a long time if you've had one of those cars. And an advantage is you get locked out, you leave your keys in there, you call OnStar, and they unlock them for you. They can tell when your car is being stolen, and they can cause it to slow down and come to a stop remotely if it's been stolen. That's a nice feature. That's something that attracts people. But the door is open as soon as they internet connected it to anything. Now, I'm guessing that the OnStar system is GM proprietary and not an open system, so that there's no way directly for hackers to get into your car. But people are now starting to connect, 4G to your car and then Wi-Fi within your car, which means it's now got the door open, right? And I don't know exactly how they're going to solve it, but like I say, I'd be asking this question in the showroom floor.
Moving up on the stack, you're talking about CoOp.
Yeah.
And sometimes it strikes me that CoOp is sort of going backwards in a way. I mean, IPVs, the reason why 15.4 and other radio technologies have adopted IPv6 presumably is because a lot of people know it. It's the common language. Upstairs, the common language is HTTP. There's a new version of it. Have you heard, because you probably talked to a lot of people who are very interested at that layer, have you heard of people saying, well, rather than CoOp, we'd rather use HTTP2, which is...
Well, or 5. When I was mentioning the ways that the Bluetooth SIG has, the first way is HTTP and a RESTful API that takes, if you build a browser with particular capabilities and explain it to it basically how to drive a Bluetooth low energy device directly, it converts those things into HTTP gets and puts, sends them to the gateway, which then converts them into native stuff. When I was talking earlier about how I would deal with the conflict between IPSO versus native GATT, what we would wind up doing is building basically the GATT RESTful API version of those native things. So from the far end point, they look the same, but they're lower power, lighter at the far end. I think I got distracted, but yeah, we're working around HTTP now as well as CoAP now. What I did put up there is, I've written several articles on the subject, and there's another one that's going to be published in April, and it's basically this presentation. And it's got a lot more references. Is that a good enough answer? All right. Thank you for hosting me here. I have cards if anybody wants to find me.